Hi, hello everyone. This is Uday Kumar, working as an assistant professor in the Department of Mechanical Engineering and the FME department in the St. Martin's Engineering College. Today we are discussing by the topic is engineering scales. Okay. Then, for example, we are discussing by the scales concept. The scales. For example, the entire engineering is depends upon the scales concept only. Okay, now the define the scales. For example, the scale is used to measure the dimensions of the object. The scales is used to the measuring the dimensions of the object. Okay, the dimensions of the object. The for example, now the measuring we are discussing. Okay, the measuring the entire in engineering, all the engineers is one of the language to communicate in the engineering field. It is first of all the measuring concept, and second one it is a dimensioning. Okay, the some for example some of the manufacturing companies is depends upon the measuring and the dimensions. It is designing the components. After designing the component, it will go for the manufacturing components. Okay, we'll discuss the measuring concept. The measuring is the three types. For example, the first one is enlarging scale. The enlarging scale. And second one is a reducing scale. The reducing scale. And the third one is the full scale. For example, the first of all, the measuring the enlarging scale. Okay, enlarging scale, we need to manufacture. Okay, we need to manufacture the railway components, the railway components, and airlines, and gears, and civil construction building. The civil construction building. Okay, now the railway components. The railway components, it is the railway components having the number of kilometers from the New Delhi to, for example, the Kanyakumari is there. It's having the 500 kilometers is there. Okay, then the 500 kilometers we need to represent in a Google map, or we need to represent in a drawing sheet. Okay, that drawing sheet is in the A4 mode or like A3 mode. Our drawing sheets in A4 comma the A2, some the different types of the drawing models is there. Okay, in that one we need to represent 500 kilometers. It is not possible to represent in the A4 paper. Okay, for example, we are observing by the one video. In this one, we are observing by the small video. In this video, it is used to measure the dimensions of the object. Okay, it is used to measure the dimensions of the object. In this video, for example, we need to prepare the one components, like it is one of the building constructions is there. Okay, now in this building construction, here one dimension is there, and second one dimension is there. Okay, this long distance is within the meters. It is used to manufacture within the meters, and the vertical beams also used to manufacturing in the meters. This meters is we are reducing the scale. Okay, it is used to reducing the scale by using of the dimension. Whatever the dimensions we need, we are preparing by the template. That is mainly in the designing concept. Okay, designing concept we are here preparing. After designing concept, it will goes to the implementing on the AutoCAD level. Okay, now it is the enlarging scale, and next one, the enlarging scale is used to measure the dimensions in The enlarging scale is used to measure the dimensions in within the it is used to measure the dimensions of the object in kilometers. Okay, and the next one next one is the full reducing scale. The reducing scale, for example, we are discussing about the reducing scale. In the reducing scale is used to manufacture the micro components. Okay, now the micro components is the gear watches is there, some of the electronic devices is there, the microcontrollers is there. Okay, now we are measuring the dimensions. For example, the reducing scale, the first concept is the 1 mm. All engineering is depends upon the 1 mm only, right? In the 1 mm, in this 1 mm, we are divided into 1000 equal parts, 1000 equal parts in the manufacturing companies. Okay, we are not able to see and we are not able to like measure the dimension. Okay, 1 mm is divided into 1000 equal parts. For example, we are going to the 1 mm to above the 1 mm, and next one 1 mm to 1 centimeter, and next one the 1 centimeter to 1 decimeter, and third one is like meters, kilometers, and feet, inches. Okay, we know about the normal, the daily days we are using by the civil engineering, they are using by the foot and inches, and like a meters, and like a SFT, square feet. Okay, that is we are using by the enlarging scale. And now we are reducing scale. With the reducing scale is 1 mm. For example, in this 1 mm we are using by the concepts, the 1 mm, the 1 mm is divided into, first of all, the 1 mm we are using by the steel rule. The steel rule is used to measure the dimensions in 1 mm. Okay, and next one, the 1 mm is divided into 50 equal parts. The 1 mm is divided into the 50 equal parts, like a 0.02 is used to measure the dimensions of the vernier. The vernier caliper is used to measure the dimensions of the 0.02. Okay, now it is possible by using of the vernier caliper. And the third one is the screw gauge. Okay, like micrometer. Now the manufacturing companies is depends upon the micrometer. Now processing of the micrometer. Now the first of all, the steel rule, by using of the hand tools we can use to mark the dimension, and hand tools it will be possible for the error of 0.01 or 1 mm error, there is no issue. And the vernier caliper is used to some of the smaller machines. The machine sees cut the dimensions of the object within the accurate dimensions. Okay, it is a 0.02. The micro machines, the micrometer may be used in the some of the numerical controlling machines. Okay, the numerical controlling machines. And next the micrometer is, the value is 0.01, and next the 1 mm is the main important. The 1 mm is divided into the 1000 equal parts. The 1000 equal parts is 0.003 is a plus or minus. Okay, the maximum, the majorly the companies are accepting the error between them 0.003 by using of the air gauges. By using of the air gauge is used to measure the dimensions of the 0.03. It is, for example, the railway is entirely controlling by the air braking system. Okay, in this air braking system we need to prevent the air as per the compressor. Okay, if the air is outlet from the tank, to prevent the air by using of the lapping between the one component to another component, it is 0.0032 we can maximize. Okay, this is called as the reducing scale. And the next one is the reducing scale. And the full scale, the full scale the full scale is used to measure the dimensions. For example, one pen is there. Okay, this pen having the 10 to 12 centimeters. Okay, 10 to 12 centimeters is there. In this pen, the 12 centimeters is directly designed is possible on the pages. Okay, now for example, one page you have to take the drawing sheet, we can directly measure the like pen, pencil, like eraser, sharpener, the normal components, whatever the dimensions between the 10 centimeters to the 30 centimeters, the dimensions is measured in the full scale process. For example, where in this one the mainly the scale is depends upon the first concept is representative fractions. Okay, the representative fractions, the representative fractions, the representative fractions. Okay, in this one the representative fractions, for example, the one destination to another destination. Okay, we are coming to the first process, the reducing scale. Now in this reducing scale, for example, the New Delhi to the Kanyakumari or the Kashmir, like Kanyakumari, the distance is 500 kilometers. Okay, then we are not able to draw 500 kilometers on the paper, right? Okay, now here the 500 kilometers is represent in a Google map 5 centimeters. 5 centimeters. Okay, for example, one building is there, the one building having the 15 floors. Okay, in this 15 floors, one floor is represent on a 1 centimeter. Okay, like that it is a representative fraction. The representative fraction is mainly depends upon the formula is actual length, actual length, actual length used in drawing by original, the original length of the object. The mainly the actual length equal to the actual length used in drawing. Our drawing as per our convenient is the 5 centimeters. Okay, this 5 centimeters is actual length, and the original length of the object equal to the 500 the kilometers. Okay, it is called as a the representative fractions. Okay, and the representative fractions too. Next we are finding the maximum. The second case of the object is the maximum length, maximum length into RF equal to total length, the total length. Okay, it is the main second formula. The maximum length they may be given by the 6 kilometers or something else they will give, and RF we know the value of the RF, and we can find the total length of the object. Okay, now and before we are discussing the problems, and then we need to know how to divide the line into equal parts. Okay, for example, the one line is given. In this one, the one line is given, the component is by using of the different types of the scales. Okay, the set squares, we need to get the accurate dimensions of the object. There is no error between the 1 mm to the 2 mm. Okay, in this one, for example, the one question, the first one, the 60 centimeters line is divided into the 6 equal parts, the 6 equal parts. Okay, then easily we can find the dimensions, right? Okay, then 60 by 6 equal to, you will get the 10. Okay, the 10 centimeters. Now we can mark from 1 2 3 4 5 6 7, like we need to mark the 6 equal parts with the accurately dimensions. For example, they may be given by the dimensions the 60 instead, they may be given by the 67 centimeters. You can divide into the equal parts, the exactly accurate dimensions we need to divide that dimension. For example, the equal parts we are dividing into one vertical line and a horizontal line. Horizontal line, we have to take the horizontal line. Okay, this is one of the horizontal line. This distance is 600, like this distance is total dimension is 67 centimeters. Okay, that 67 centimeters by using of the 2D, the 2 dimensions of the object. Here we can mark the dimension. This dimension is 67. Okay, now the 67 we can divide it into equal parts. How many equal parts? As per given, 6 equal parts. Okay, Now you can rotate the protractor. Now mark the dimensions of the one object. You can measure the dimension in the accurate mode. Okay. Now check the dimensions. You mark the first one. You mark the first one and take the angle. Take if any angle, whatever the requirement is there, if they may be given, we are divided into some equal parts means we are taking the angle with the accurate dimensions. Okay. The first of all, we need to take from 0 to 90 degrees. You can take the any one angle. For example, I am taking into the 30 degrees angle. I am taking into the 30 degrees angle here. Draw a one line. Draw a one line with inclination. In this inclination, you can erase the whatever the unnecessary part. Now in this inclination, you can mark the dimension in the equal parts should be maintained of the below. Here equal parts for a 1 2 3 4 5 you can need into how many parts you require, that parts you can mark the dimension 1 2 3 4 5 and 6. Okay. Now the end, whatever the end point is there, that you can mark to the dimension, the 0, the 1 2 3 4 5 and 6. The end portion is there, right? This end portion you can join to the line by using of the set squares. The long scale is needed. This long scale is needed to mark the dimension. The sixth line is joining to the end line. Okay, this end line. Okay, now this end portion you can draw a first line, the first line, and all lines should be parallel to each other. One line to another line you draw at the parallel to each other, you will get the accurate dimensions of the object. The first line and the second line and the third line and the fourth line and the fifth line. You mark the dimension 0, 1, 2, 3, 4, 5 and the sixth. You will get the 6 equal parts, and now accurately you will get the dimensions by using of the angular method. It may be given by the horizontal line. Okay, for example, they may be given by the vertical line. How we can draw the vertical line? You can take the same angle, the same process for the vertical line also. You need to draw one vertical line, whatever the dimensions. For example, the 60 dimensions is given. The 60 dimension you need to draw one vertical line. In this vertical line, you mark the dimensions of the object in 1 centimeter or like a 1 kilometer. For example, here they may be given by the centimeters, right? The centimeters, first of all, I am marking the dimension from the top object onwards. Okay, you need to check the protractor in the accurate dimension or not, you need to check. Okay, I am taking the angle is 30. I am taking the angle is instead 30, instead you can take the 40 or 30, or there is no issue. And 40 we are taking the one angle. In this angle you need to divide into 6 equal parts by using of the vertical line. It is one of the vertical line. Okay, this vertical line we need to divide into the 6 equal parts. The first one and second one, third one, fourth one, fifth one and sixth one, and finally the same process is applicable, and the last end point to join the first line. Join the first line. Okay, join the first line. This is the end portion of the object. End portion of the object. The first line and the second line, need to draw the second line, and third line also we need to draw a third line with you will get the accurate dimensions. These lines are parallel and perpendicular to each other as per given the dimension. Okay, after completion of this one, you need to mark the 0, 1, 2, 3, 4, 5, 6. You will get the line is divided into the equal parts. Okay, now we are observing by the one PPT here to mark the dimensions of the object. In here we need to mark some different types of the dimensions of the object. Okay, here for example, this is the enlargement of the scales. Enlarging scale, reducing scale and a full scale is used to mark the dimension. The mainly representative fraction, the representative fraction we are already discussed in the representative fraction, length used in drawing by original length of the object. For example, the 1 centimeter, or instead they may be given by the 1 kilometer. Okay, now the mainly the scales are the two types. First one is the plane scale and a diagonal scale. The plane scale and a diagonal scale. Okay, in this plane scale and a diagonal scale, it is used to measure the dimensions in the two category only. Like subdivisions is there. First of all, 1 mm, 1 mm2 is divided into the subdivisions. 1 mm2 is divided into subdivisions, and second one is also divided into the micro level. Okay, the plane scale and a diagonal scale, by using of the plane scale and diagonal scale, the first of all, the plane scale is maximum. The plane scale, the first of all, the plane, here we are discussing by the plane scale and the diagonal scale. The scales are the two types, the plane scale and the diagonal scale. The plane scale and the diagonal scale. The plane scale and the diagonal scale is depends upon the dimensions. Okay, now we are discussing by the scales. The scales are the two types. Scales are the two types. First one is the plane scale, plane scale, and second one is the diagonal scale. The diagonal scale. First one is plane scale and second one is the diagonal scale. Okay, in this plane scale is depends upon the dimensions. The dimensions, like a units, dimension means it's having the units with MKS and some of the process of the units is there. Okay, in this units is divided into two types. First one is metric, the metric, and second one is British. Metric and the British. Metric is a very important. Now all the engineering standard is using by the India is following by the metric standards, and the British is a different. Like US is following by the US, Germany, that components that some other states is follow, other countries is following by the British components. For example, metric we will discuss. The metric is first one, and the main value is 0.01 equal to, for example, 1 mm by using of the micrometers. Okay, and 1 mm, like the 10 mm equal to 1 centimeter. 10 mm equal to 1 centimeter. And now the 10 mm instead, for example, the 10 centimeters equal to 1 decimeter. 1 deci, 10 centimeters equal to 1 decimeter, and the 10 decimeter equal to 1 meter. 10 decimeters equal to 1 meter, and 10 meters equal to 1 decameter. The decameter, okay, 1 decameter, and the 10 decameters equal to 1 hectometer. 10 decameters equal to 1 hectometer, and 10 hectometers equal to, the hectometer equal to 1 kilometer. Okay, already everyone know about the kilometers, right? Up to 1 mm. It is a relation between the kilometer to 1 mm. Now here we are discussing by the British standards. For example, the 0.01, the mm equal to 1 centimeters. We know the 1 centimeter, right? Okay, the 1 centimeter, the 10 centimeter, the 1 centimeter. Here the 2.54 is the 2.54, the centimeters equal to 1 inch. The mainly civil engineering is depends upon the inches topic only. Okay, now inch, okay, like the 12 inches equal to 1 feet. Okay, the mainly discussing by the feet, from feet to the, like the 3 feet equal to 1 yard. 3 feet equal to 1 yard, and now 3 feet equal to 1 yard. The 22 yards equal to 1 chain. 22 yards equal to 1 chain, and 10 chains equal to the 10 chains equal to 1 furlong, 1 furlong, and 10 furlongs equal to the 10 furlong equal to the 10 furlongs equal to the 1 mile, 1 mile comma 1 league. 10 miles equal to 10 furlongs equal to 1 mile, and 3 miles equal to 1 league. Okay, we are discussing here as per the PPT 1 league. In this one, we are discussing by the object here 2, following by the plane scale and the diagonal scale of the components. Here the mainly the plane scale is the 2 types. First one is the plane scale and the diagonal scale. Okay, now we need to reducing the one scale upon another scale. By using of the next, we'll discuss one problem regarding the plane scale. Okay, the plane scale here, the first one is the plane scale. The plane scale, one, draw a 1 centimeter, the 1 centimeter to read decimeter and meter. The maximum distance is 6 kilometers, and show a distance of 4 meters and 6 decimeter. Very very important the problem. It is construct the RF. RF equal to dimensions of the drawing. Dimensions of the drawing by dimensions of the object. Original length we are using in the drawing by dimensions of the object. We are finding the RF equal to 1 centimeter is representing in a 1 meter. 1 meter equal to is 10. 1 by component is 1 by 100. We will get the 600. 100 get cancelled. 1 by 6 equal to 6 kilometers. 6 they may be given by the 6 centimeters. Okay, now draw a line. First of all, this line you need to draw 6 centimeters. This 6 centimeters is, we are divided into how many equal parts as per the maximum distance. Okay, we are divided into the 6 equal parts. Okay, first one, second one, third one, and fourth one, and the fifth one. We are divided into a fifth one, and finally we are divided into the 6 equal parts of the object. Okay, we are divided into the 6 equal parts. Now in the 6 equal parts we need to mark dimensions. Is the first one you can take the 0, and second one is you can take the 1, and you can indicate the third point is, the third point is 2, and next we can indicate the mark the dimensions in the third point, and next mark the dimension from 3 to 4 is divided into 10 equal parts of the object. Okay, 10 equal parts of the object from 10 to the 4th to 5th. Now it is in the meters. The meters is the 10, right? Okay, from 0 to 1 we can divide it into 10 equal parts. Here we are the 10 equal parts. Okay, for example, the 5th part is there, right? The 5th is the 10 centimeters. 10 like 10 centimeters. We need to mark the distance is the meters, read decimeters, and to measure the maximum distance of the object. Okay, now we can divide it into 10 equal parts of object. 4 meters and 6 decimeters we need to draw. 4 meters and 6 decimeters. The 4 meters equal to, for example, we are using by the one scale. This scale 4 meters is there. We need to mark the dimension. For example, one destination to another destination. One destination to another destination. One destination is given by the principal is New Delhi, and second one, the destination is to mark the Kanyakumari. Okay, here from 0 to 1. Okay, in between them point is the total length is 6 kilometers. Now here in between the point is 4 meters and 6 decimeters. We need to mark the 4 meters and 6 decimeters. First of all, you need to mark the meters here. Okay, now here the meters is in the 10 equal parts, and 4 to 5 is the 10 equal parts, and 4 to 3 is also 10 equal parts, and 3 to 2 is also 10 equal parts, and second point to 1 is a 10 equal parts. Here the total distance is 6 centimeters is represented in the Google map equal to 6 meters. Okay, the 1 meter equal to 10 decimeters as per the unit. 6 meters equal, like 6 meters equal to how many decimeters? 6 meters equal to the 60 decimeters. Now here they may be given by the dimension is 4 meter and 66 decimeters. Like 4 meters equal to the 4 meters equal to, like this one is the 4 meters. The 4 meters equal to 40 decimeters, and the 6 decimeters we need to mark 46 decimeters. Now each equal part is a 10 decimeter, right? And next one, it is a decimeters, this is the meters. Okay, we need to change the dimensions by using in the engineering the lettering format the meters and the decimeters. And next, mark the RF value. The RF value equal to 1 by 100. It is a plain scale, is used to mark the dimension, the first one. And the second one, it is used to mark the dimension, the 4 meters to 6 decimeters, for using of the plain scale concept. Okay, now here to mark, if any, they may be given by the, if any components, okay, they may be given by the, if any one component, you can go through the plain scale and the diagonal scale. Okay, now thank you everyone.